This is the second part of lesson 12.3, box and whisker plots. Okay, so picking up where we left off, we're going back to 27 now. And what we're going to talk about right now is using different measures to compare things. And so when we talk about comparing things, one of the things that we talk about is the measures of central tendency. So if we're looking at the measure of central tendency, there are three of them. So mean, median, and mode. And depending on what we're trying to make somebody think, we might choose one over the other because it's more persuasive for what we're trying to get them to think. And so statistics are used a lot of times to sway people and to help, kind of mold their thinking into what somebody wants them to think. And so we're going to look at that. One thing to keep in mind is that when you're doing this, you're not telling a lie. You are choosing your truth, I guess. And so let's take a look at Kathy here. So it says Kathy earned the following scores on her last 7 math quizzes. So here we've got her scores that she earned. Her grandparents want to know how she's doing in her math class. And she's trying to impress them. So maybe, they're going to give her a cookie and $5. And so she wants them to think that she's doing really great. So which measure of central tendency is she going to tell them? So before I can decide if she's going to use mean, median, or mode, let's find those three things. So I'm going to come and put those numbers in order so we can find mean, median, and mode. So I'm going to put them. So I've got 14, 14, 14, 17, 18, 18, and 20. And so as far as the mean goes, we're going to add those together and divide by 7. And so we get that her mean is 16.4. So let's write that down. So we're going to write the mean is 16.4. That's a symbol for mean. This is also the symbol for mean, so both of those. The median is going to be the middle one, so that's going to be 17. So I'm going to say median is 17. And then the mode, the one that she sees the most often, is the 14. So we've got 3 measures of central tendency. They're all different. And so if she is trying to make her grandparents think that she's doing well in math, which one of those will she tell them? So which one makes her look smarter? Which one makes her look better? So hopefully you're thinking, well, if she's trying to make it look good, we want to use the median. And that's true. So when we explain that, we're not going to say, well, Grandma, I have a median test score of 17, because maybe it's been 60 years since Grandma's taken math and she doesn't remember what that means. So let's explain that in a way that she can understand or that anybody can understand. So how are we going to say about the median? So I want you to think about that. Write a sentence for how Kathy's going to say it to her grandma so that her grandma will understand. Okay, my idea for doing this is to say something along the lines of, great, half the time, or half of my scores are above 17. Okay, that's true. She is not telling a lie. That is true. She's choosing her truth that she's going to give them. Okay, so half of my scores are above 17 or above 17 out of 20. And Grandma's like, great. And Grandpa's like, here's $5. And so that's great. So that's what Kathy is going to tell her grandparents. Now we're going to take Kathy home now. She's going home from Grandma and Grandpa's house, and she's thinking about math because they had just asked her. So she's been thinking about it, and she knows more information than what she told because she knows what all of her scores are. And she's starting to think about it, thinking, well, I'm kind of worried actually because I have these other problems in math, and I'm kind of worried that I need a tutor. So she gets home and she says, hey, Mom, will you hire me a math tutor? I need some help in math. And her mom's like, well, I just got off the phone with Grandma, and she says you're doing great in math because half the time you get above a 17. What is Kathy going to tell her mom? Because she needs to persuade her mom that she needs a tutor. So if she pulls the 17 again, that's not going to help make Mom think she needs a tutor. And so which of the measures of central tendency will she be giving to tell her mom? And then how should she say it? Because if she sounds like too technical, then her mom's going to say, see, you know what you're doing. So how should she word it so that her mom understands what the problem is? Okay, so hopefully you decided that she's going to use the mode because that's the lowest score. That's the lowest average. These are all different types of averages, but that's the lowest one. And so how do we say that though? Because if we say, well, my mode score is 14, Mom's going to say, well, it sounds, like you know what you're talking about because you're using the word mode in a regular sentence. And so how can she say it? So my idea for this, and yours might be slightly different, but it's going to be along the same lines, is that the score I get most often, or the score I get the most, is 14 out of 20. And that's not a good grade. Now, you do not want to say most of the time I get a 14, because that's not true. Okay, most of the time you do not get a 14, or Kathy does not get a 14. So you have to think about how you say it. So when it says to explain what you're going to say, you need to think about, is that true? Is that exactly like what I mean by that? What does that word mean? How can I explain it? And you want to explain it to the general public, not somebody in math class that just learned about those definitions. Okay, let's try another one. We're going to go to 36 now, so skip over to 36. Okay, a company pays their employees the following yearly salaries. So here's how much they're paying their employees. They've got somebody down there at $12,000 a year, so hopefully they're working like not very much. And then all the way up to $90,000 a year. Okay, so I want you to find the mean, median, and mode for those salaries, and then come back and we'll talk about those numbers. Okay, you should have found the mean, median, and mode. The mean is $55,200. The median is $60,500, and the mode is $72,000. So with those numbers, okay, we found, I guess I should have written that down here. So my mean is $55,200. Median. So each of these tells a little bit different story. Okay, so depending on what you're trying to make somebody think about this company, you might use something different. And this is done all the time. If somebody's trying to make a community seem more prosperous, then they might use the median income or salaries that people in the community make. If they're trying to make a community look less prosperous, they maybe will use the mean. It just depends on what they're trying to make people think. So keep that in mind as you go throughout life. And if somebody's like pulling statistics out at you and they say like, well, the median salary, ask yourself why they didn't tell you the mean. Is there a reason why? So maybe ask about the other one. So let's take scenario B. You are trying, so you're the boss, okay? You're trying to hire a new employee and you want it to appear like you pay well. So you can see like some people get paid well and some people not so much. But you want this employee, like you want him to come work for you, so you want it to sound like you pay well. So which of the measures of central tendency are you going to tell the person about in order to make them think that you pay really well? Now keep in mind as you explain that you are going to tell a true statement and you need to put it in regular people terms, not math class terms. So make sure you say it in a way that they'll understand. So go ahead and write a sentence that's going to explain what you want them to think. Okay, hopefully you decided to use the mode because that's the highest, and so you want it to look like you pay a lot, and so that's the one you would use. But how you say that is going to be important. You're not going to say most people get $72,000 because that's not true. Out of all the people, 2 people got $72,000. So that's not a true statement. So how do you say it? You can say $72,000 is the most common salary. That's true. Okay, you can say more people get $72,000 than any other salary. That's true. If somebody quotes mode to you, I probably wouldn't be that persuaded though. But anyway, you could say something like that. You just don't want to say something like most people get $72,000 or most people, because we're not talking about most people. Okay, now right after you get this employee to come and work for you, thinking that they're going to get $72,000 because you quoted the mode to them, the owner of the company, so your boss, comes in and he's mad because like, why are we paying people this much money? And how come $72,000? And you're like, oh, calm down, because he does not want to pay any more money than he has to. So you now need to switch gears, and now you need to convince your boss that he doesn't need to worry because we're not paying people that much. So which measure are you going to use now? Keep in mind, people's salaries have not changed. What's changing is the truth that you're going to put out there. So if you're trying to make your boss think that we're not paying that much, you're not going to use the mode. You're going to go for the lowest number. So we're going to use the $55,200. So you're going to say something like what? What are you going to say? You're going to say, we only pay an average salary of $55,200, not anywhere near the $72,000. So calm down. So something along those lines. So say something that say on average we only pay $55,200. So that's just, to make it a lot more feasible, I guess. So as you're doing these types of problems, you're going to look at these three measures of central tendency, and you decide, depending on what you're trying to put out there, what you're trying to make somebody think, which one do you use, and then how do you say it. Okay, the next thing we're going to do for this lesson is we're going to talk about standard deviation. So if you remember, this is another measure of variability along with the range and the interquartile range. Now the word variability or varies, I spelled that wrong, variability. That just means that something changes. So if the weather varies a lot, then it changes from hot to cold and everywhere in between. So the standard deviation is a measure of variability. So it's telling us how much things are changing. Okay, the symbol for standard deviation is this Greek letter sigma. It's like a little circle with a hat on it, and it's usually followed by X. Okay, so it kind of looks like ox, but it's not. There are different types of standard deviation. This one we're talking about is the population standard deviation. We're not going to learn any other types of standard deviation or to distinguish between them at all. If you do college level statistics, then you'll learn that. But for this class, we're only doing that. So that's the only one you need to worry about. Okay, it is calculated as the square root of the variance. So that word variance. Okay, so here's how you find the standard deviation. So get ready. Okay, we're going to find the standard deviation of this set of numbers. So this first one is 11, in case you can't read that. 7, 10, 5, 1, 3, 7, 4. So the first thing we're going to do is we're going to find the mean. So add them together and divide by 8. So we're going to take 11 plus 7 is 18, and then we've got 10 plus 5, and then we've got 4 plus 11. So add them all together, divide by 8, and so you're going to get the mean. And so the mean for that should come out to be 6. So I'm going to say that the mean is equal to 6. Okay? Now the next step is we're going to find the difference between each data point. These are our data points and the mean. So I'm going to take each data point one at a time and I'm going to find the difference. So between 11 and 6, that difference is 5. 7 minus 6, that difference is 1. 10 minus 6, difference is 4. 5 minus 6, that difference is negative 1. It's okay that it's negative. Don't worry, it's negative 1. 1 minus 6 is negative 5. 3 minus 6 is negative 3. 7 minus 6 is 1, and 4 minus 6 is negative 2. So those are my differences from the mean. So I've got these numbers right here. Okay, now the next thing you're going to do is you're going to take each of those numbers that I boxed in yellow there, and you're going to square each one. So 5 squared is 25. 1 squared is 1. Okay, now that's not going to be hard, but when you get to these ones that are negative, the negative one, remember that we're asking what that squared is, so it means negative 1 times negative 1. If you, hopefully you wouldn't do this, but if you type this in your calculator like that, it's going to tell you the wrong answer. That's not what we want. It's negative 1 times negative 1, so it's a difference of parentheses or not. So I'm going to write down all of the square numbers there. So I'm going to take 5 squared, I'm going to do 1 squared, 4 squared, negative 1 times negative 1, negative 5 times negative 5, negative 3 times negative 3. Okay, those are my numbers that are the difference between the mean and the data points. Okay, so now I'm going to take those numbers. I wish I would have done them all in the same color. And we're going to find the mean of those numbers. So I'm going to take 25 plus 1 plus 16 plus 1 plus 25 plus 9 plus 1 plus 4. And I'm going to add them all together and I'm going to divide by 8. So go ahead and calculate all of that. You are going to have a decimal on this one, and that's okay. Keep the decimal. You don't want to round on decimals until the very end when you absolutely have to, because if you use a rounded number, as we've seen before, you get a different answer. So when you add up all of those and divide by 8, you should get 10.25. So make sure that that's what you're getting. The very last step in order to find the standard deviation is we're going to take the square root of 10.25. And we're going to have to round now because we're at the end. So that's going to come out to about 3.2, and that's going to be our standard deviation. Okay, what that means is it's telling us how much the data is varying, and so the standard deviation is 3.2. If you have a bigger standard deviation, that means the numbers are going to vary more. If you have a smaller standard deviation, they're going to vary less. In the next lesson, we will learn how to use standard deviation, what we do with it, what it's used for, but for right now, we're just learning how to find it. Now, the good news is that I'm not going to make you do that by hand anymore, okay? So this is doing standard deviation by hand. It's kind of a lot of steps to remember. You don't have to remember those. You're not going to have to do that. What you are going to need to do is be able to do it on your calculator. So if you go to the back of your book in the appendix, you find a page that says how to find the standard deviation. At the top of the page is how to do it with a graphing calculator, but most of you have this calculator. Now, if you have something besides a TI-83 or 84, the graphing calculator, or this TI-30X2S, then you can either look up how to do it on the internet, or you can come and ask me and I can help you do that standard deviation. Okay, we're going to practice putting this in our calculator to find the standard deviation. So here's our data. It's already in order for us, okay, because that helps. If it's not in order, you should put it in order before you put it in your calculator. It will help a lot. So I'm going to now show you, showing the calculator, how you're going to enter all this data. The steps are all on the screen right here and in your book, and you want to do this often enough that you'll remember how to do it. But for right now, I'm going to go ahead and just show you on the calculator. Okay, I'm looking at about page 263 in your book on the appendix. It's appendix number 3, and these are the directions that we're about to follow. So I'm going to put that information into my calculator. So I've got the calculator right here. This is the 30X2S, and if you don't have this calculator or the graphing calculator, you're going to want to look up how to do it or come and get some help. So I'm going to enter my data. So first I'm going to do second, so clear out whatever I have. I'm going to do second and then data. And it says you see one variable or two variable. And so I'm going to hit enter. And so now you see right there on the screen it says stat, and that means I'm in stat mode. If you don't see that, then you need to go back and do that again. Okay, the next thing is we're going to hit data, and it says X1. You're going to put 5 in there because that is the first data point that we have. So I'm going to put 5 in my calculator, and then I'm going to go down, and it says frequency. And I look at my data, and in my data I have 1, 2, 3, 5s. So for my frequency, I'm going to put 3. Okay, next I'm going to go down, and it says X2. So I look at my data, and the next number is 6. So I'm going to type in 6. And then I go down. How many 6s do I have in my list? I only have 1, so I'm going to just keep the 1, and then I'm going to go down again. The next number up is 7. 7. How many of those do I have? I only have 1, so I'm going to keep the frequency 1. Next one is 8. I only have 1 of those, so 1. Keep going down. The next one is 10, and I have 2 of those. So if you look at my list, I've got 2 of the 10s. This is why you want to put your list in order from least to greatest. So I'm going to put, for frequency, I'm going to put 2. And that's the same thing as if you put 10 in your calculator twice, so 10, 10. Okay, and then I'm going to go down, and then I'm going to type in 12 because that's the next number. And if you look at your set of data, you have 4 12s. So I'm going to go frequency, and I'm going to say 4. And then I'm going to go down, and the last number I have is 14, and I only have 1 of those. Okay, so now I am about right here on my on my list of instructions. So I've done all of the frequency things. So now I'm ready to do this step. So I'm going to say stat var. So that's going to be this button right here. So I'm going to do that, and it says calculate. Okay, now look at what it has across the top there. It's got in, and it says 13. That's because I have 13 numbers that I entered. If you look at my list of data, I've got 13 numbers. That's where that's coming from. Okay, next to it is the X with the line over it. So if you use your right arrow, that's the average. That's your mean. And so if you need to know your mean, your calculator can find it for you. So you could say 9.077 or 9.1, depending on how you're supposed to round it. Now, this next thing is very important. You see where it says SX? That's a different standard deviation. We do not want that one. Don't do that one. So you're going to keep going past that one. Notice how it's different, and I'm going to go to the population standard deviation. That's the one I want. So you see these two are different standard deviations. They mean different things. We're not going to get into that. So this standard deviation is what I want. So make sure you know to look for that one. So this one I would say is 3.1. Okay, and then if you go one more time over, you get some other stuff. That's not really important. If you were looking at the steps that we did when we did this by hand a few minutes ago, you would recognize those numbers, but we're not doing that. So really the only thing you need to worry about is that standard deviation and the mean. And that's how you do that on the calculator. Now, if you want to do another problem, it says to clear your list, you can't just say clear on the calculator, because what it does is it clears like the current thing, but if you went to stat var again and you did it again, it's still there. Okay, so that's the problem. So it says what you do is you go to second data, go right until it says clear data. So we're going to go second data, and then we're going to go right past the 1 var, past the 2 var, and to clear data. And then you're going to hit enter there, and then it's going to be cleared out. So now if I do stat var, there's nothing to do. That's why it says error. There's no data in there. So that's what you want before you start a new problem. If you don't do that, it's going to keep some of your old data and mess up your numbers. Okay, one last thing about this. On your homework, there's a question that has to do with the age of presidents when they died. And it says for this amount of data, use either your graphing calculator or Desmos. It doesn't have to be a graphing calculator. It can be this kind of calculator. So there are instructions in your appendix how to use a graphing calculator if you have one, or how to use Desmos. I want you to be able to use a calculator and not go to Desmos. So on your test, you cannot go to Desmos on your test. So you need to know how to use one of the calculators to do this. So just make sure that you're able to do that.